Hi, my name is Destiny Tudara, and this is Tudaratutors. Today I'll be going over related rates from Calc 1 and also general related rates tips, as well as two specific examples. So if you want to learn more, stay tuned and we'll get through this together. General related rates tips. Draw a picture. Assign variables to all changing values. List everything you know. Label your picture with variables and constants. Do not assign a variable to a constant to avoid confusion. Name what you're looking for in terms of what you know. Find a relationship between what you know and what you're looking for. If there are too many variables, find a relationship to eliminate one. Differentiate in respect to time. Answer the question asked. The two questions we'll be going over today are: at 2 p.m., Ship A is 85 kilometers west of Ship B. Ship A is sailing south at 45 kilometers an hour, and Ship B is sailing east at 23 kilometers per hour. How fast is the distance between the ships changing at 7 p.m.? The radius of a right cylinder is increasing at the rate of 8 inches per second, while the height is decreasing at the rate of 9 inches per second. At what rate is the volume of the cylinder changing when the radius is 7 inches and the height is 20 inches? At 2 p.m., Ship A is 85 kilometers west of Ship B. Ship A is sailing south at 45 kilometers an hour, and Ship B is sailing east at 23 kilometers an hour. How fast is the distance between the ships changing at 7 p.m.? So we're going to draw a right triangle because we have our starting point, and Ship B is traveling east while Ship A is traveling south. So from 2 p.m. to 7 p.m. is 5 hours. And we're given the rate of change for both Ship A and Ship B. For Ship A, it's 45 kilometers an hour, and Ship B, it's 23 kilometers an hour. But we're trying to find dc over dt, which is, c is referencing the hypotenuse, which is the distance between A and B, and we're trying to find that in respect to time. So for Ship A, we're going to multiply 5 times 45 kilometers because 5 hours have elapsed. And we're going to get 225 kilometers for Ship A. For Ship B, we're going to multiply 5 times 23 kilometers, but we're also going to add that 85 kilometers that was given to us in the problem because Ship A is 85 kilometers west of Ship B. So we're going to get 200 kilometers for Ship B. We're going to solve for C using the Pythagorean theorem. A squared plus B squared equals C squared. When we plug in 225 squared plus 200 squared equals C squared, we get C equal to the square root of 90,625. Now we can differentiate with respect to time. So we have A squared plus B squared equals C squared, and when we take the derivative of each term individually, we have 2a multiplied by dA over dt plus 2b multiplied by dB over dt is equal to 2c multiplied by dc over dt. So this is where organization really helps because when you label things, now we can just plug and play. So we have 2 times 225 multiplied by 45 plus 2 times 200 times 23 is equal to 2 times the square root of 90,625 multiplied by dc over dt. So we're trying to get dc over dt by itself because that's what we're solving for. I always like to put a question mark next to what I'm trying to find, so it kind of reminds me, I'm like, oh hey, like, that's what I'm looking for. So when we just do basic math, solve for both sides, and we end up getting 14,725 over the square root of 90,625, and when we punch that into the calculator, we get approximately 48.914 kilometers per hour. So the answer to the question is, at 7 p.m., the distance between the ships is changing approximately 48.914 kilometers an hour. The radius of a right cylinder is increasing at the rate of 8 inches per second, while the height is decreasing at the rate of 9 inches per second. At what rate is the volume of the cylinder changing when the radius is 7 inches and the height is 20 inches. So we're going to start by drawing a right cylinder, and we're going to jot down the volume formula for a right cylinder, which is pi r squared times h. And we're going to write what we're trying to find in terms of what we know. So we're given the rate at which the radius is increasing, which is 8 inches per second, and we're writing that in respect to time. We're given the rate at which the height is decreasing, which is 9 inches per second. And we're trying to find the rate at which the volume is increasing when r equals 7 inches and when h equals 20 inches. So we have our volume equal to pi r squared times h. We're going to use the product rule. So we have dv over dt, because we're still deriving in respect to time, equal to, we're going to factor out pi, because whenever you can factor out a constant in the beginning, it's better, just so it doesn't get confusing. So we'll have pi times 2r times dr over dt times h plus 1 times r squared times dh dt. And when we plug in all of our values, we end up getting 1,799 pi. So the answer to the question is the rate at which the volume of the cylinder is changing when the radius is 7 inches and the height is 20 inches is 1,799 pi inches cubed per second, because we're talking volume. Thanks for watching. Make sure to like and subscribe. Also, for any math-related questions or video requests, email me at tudaratutors@gmail.com or comment below.